Okay, so I got the 10-watt LED totally torn down. Got the glass off of it right here. This is off of it. And I'm going to be replacing this junky converter with this converter right here. And this is the, I don't know what it is, but you can get them on eBay for like $1. These you can get on eBay for like $1.20, even though they're smaller. Let's see if we can actually get a close-up view here. There we go. So as you can see, they're really small. And this one I think can do 3 amps for a short period of time and like 1.5 continuously. So we should be well within its tolerance, and I'm going to actually adhere it to right around here. And I'm going to actually use some tissue tape, which lots and lots of stuff on eBay will be selling this as thermal conductive tape. And the reason I'm using this over thermal conductive tape is because, one, I'm not really using this as a heat sink. This won't produce that much heat. I'm just really trying to get it to stick down. I actually got thermal conductive tape right here, and it's actually silicone, but it's nowhere near actually as sticky as this stuff right here. It also won't, it doesn't do well with curves or bends, so if this isn't perfectly flat, this type of tape won't work quite as good. It could come off. I don't want that. So, got my soldering iron all heated up, and I'm going to see if we can get this down just a little bit closer here. Remove the wires from here. I think we got that. Alright, come on now. There we go. Okay, now is there a positive and negative marker on this? Hope it looks like white's negative. I think I see a negative right there. I don't see a positive on this side. This capacitor should tell us. Yeah, it looks like it's tied pretty much right together right there. It's got the negative right there. So the white is negative. Let's desolder that. Let's give this a little bit of a pull as I'm soldering it, and there we go. That one's off. White is negative. And on this, if I remember right, the output's marked with a negative symbol. Output right there, negative. Alright. Should probably try and tint this first, but where's my solder? I'm going to at least put some solder on there. Maybe not some flux, but let's put some solder on there. If I could find the end of my solder. I just hate it when this happens. Can't be the only person that struggles with this. Alright, there we go. Let's do just a little bit of soldering. Get that heated up just a little bit. My soldering iron might not be hot enough. It's a cheap piece of junk, so you never know how where it's gonna need to be at, especially when you're soldering things that could sink away the heat. Come on, get that good now. Alright, let's turn up the soldering iron just a little bit more. So we're having trouble melting that on that board, but I think we're good enough. Alright. I'm going to actually stick this down right now. That way I got something that kind of holds it. So I'm going to cut off a chunk of this. I'm actually going to stick it to the tape. That way I know what size to make it. Like that right there. I'm just going to cut around it. If I can. Hold on. It's hard to do these things on camera. Alright, we're almost there, we almost got it. Oh, look, it tears really easy too. Oh, that's amazing. Just put that back on there. All right, we have this. Let's stick this after I get it kind of worked on there pretty good. There we go. Oops. All right. Let's just get this rubber thing out of the way, shall we? All right. Stick this on here. Oh, before I hook this up, I need to set the voltage on it. That I should definitely be doing. All right. So that means this is going to be loads of fun. Alright, let's just get this wire shoved through there a long ways. That way I got plenty of it. I actually just slid the nut down on this wire, so. And now you can't see what's going on, but hey, what you gonna do? Gotta slide this on, gotta get everything in the right order. Otherwise it won't want to go back together right. Right, this needs to face this way. Like that, pretty sure. I'll fall off. Then, which one's gonna be the positive? So now we got negative on this side. Let's make the brown or whatever this color is. I don't know. It kind of changes colors on it as you rotate it. It's kind of like a off brown, I guess, maybe slash light burgundy. I'm not sure. Let's just get that on there. There you go. Come on now. Oh, I was going to stick a diode on here. I got a diode. Now I got to solder it the correct way, right? I always get these things backwards. So often. Alright, that's negative, so positive. This needs to be stuck here. Let's get some solder in this part. Alright, if I remember right, the little notch on the end needs to go towards the negative. There we go. Alright, I feel like I should put some shrink tube on this. But I don't think I have any shrink tube, so I kind of ran out. Looks good right there. I'm just going to solder that. I'm pretty sure I got this diode going the right way. It's going to be so embarrassing if I don't, but I'm pretty good at forgetting these things. Wish this thing would stay still. I think I just got it. That looks pretty good. Nice and short lead. Where'd my little trim thing just go? There. Alrighty. Alright, that's give this thing some power. I'm gonna give it 12 volts. Gotta give, so, blue is positive. That would be this one, and then this brown one is negative. Oh, it just sparked a little bit hooking that up. All right, that was, I guess, an okay sign. I wasn't expecting it to spark. I guess it does have a capacitor on there. All right, we got let's just get this in the frame here. Maybe move it up a little bit. There we go. All right. So we got 12 volts on here. I was got 13 on this. So you can actually see we're actually dropping in voltage about half a volt from the diode. But the diode kind of protects it, so let's look at our output here. The output, if I remember right, I don't need to pull this down. Oh, look at that. It's already at 9.8. Now, that could be because of the voltage drop, and it actually is automatically just kind of trimmed there, because the last one was 9.8. And I sort of thought that, you know, that might actually have to do with That being is absolutely as high as it could make it, because it is a buck converter, I'm thinking. Can I even... I don't think I can spin that thing with this. Can I spin it with this thing? How about this thing? Ooh, there we go. That's good. Alright. That's a... Disconnect this. And I'm going to solder the weight to the ground, because that's how it was. There we go. Let's solder this to the positive. And we should be good. I see light on the other side. Look at that. It's working. Alright, so let's leave it hooked up and see what our voltage is. And we're going to be using constant voltage instead of current. So I got to be really careful. Yeah, so we should be plenty good on that. Leaves us with quite a bit of tolerance. Now it looks like this is going to work. Wow, this is a lot brighter without the lens and stuff on there. I mean, that's... See that? It's getting way more current than what it was. Alright. Maybe I should stop and measure that current. I'm going to clamp it up, because I want to make sure that, whoa! I don't know if that would have been a problem or not, but I don't think LEDs store any type of capacity, or capacitance, or have capacitance, or whatever, so it probably wouldn't have been a problem. But I don't know on those chips that are kind of pre-built, so... Now the problem with using this is it's got a resistor in it. Now I'm going to be using the fairly large resistor, so I'm getting slightly less current going through it. Yeah, we're only doing like 300 milliamps here. And that is not enough. I want to turn that up just I think I want to turn it up. I mean, it's plenty bright. Do I really want to change it? I guess I kind of actually got control over it if I want, right? This is probably simply because it's just simply down just a tiny bit. Good, you guys can see that as I'm turning it. Just a little bit more. I think that's good. That's about where I want it. I don't know if this thing's getting hot. Not even warm. Not even warm. But I'm going to leave it on there for a little bit. Let the LED get hot. You notice we're already up to 0.6 and it's still climbing. That's because the LED is getting hotter. So I might want to actually turn this down to more like 0.5. I think this direction's down. There we go. Yeah, let's leave it more like in this area, because we don't want it to get hot and then end up with more current going through it. It gets hotter, then more current goes through it. That's why you don't usually want to use constant voltage when you're running LEDs, but I'm going to be running it so low that it should be fine anyway. Alright, so I think we're good on that. We're doing, I can't remember how many amps. It was like half an amp, a little bit over. Then we're going to check the Alright, so we got that hooked up. Now we got to check the voltage. And we're definitely going to switch this back into the voltage mode, because I got multiple sockets on here because it doesn't switch on me for me. Got to put it back in voltage mode so I can read the voltage. I'm going to hook it up. check the voltage. Alright, the light is on. I'm not going to short it out because we got the different pins in there now. Okay, 9.9. Alright, 9.9 and like, I think it was 540 milliamps. Alright, so now let's measure the current going into it, which is 0.7, something like that, it looks like. And what is our voltage? 12, let's just say 12.4. And we have, pretty sure we're 0.7 going into it. Let's get these leads away from each other. I don't want them interfering with each other. Yeah, we're at, looks like 0.7 amps. Let's put the meter on there just to be safe and sure. I should be writing this down because I almost guarantee I'm going to be doing the math later for this. Alright, so I got that in there. Oh, hold on. Yeah, that's connected together. Got it on amps. We're got the light lit. It actually is reading 0.53 amps. Alright, so, and I trust this over the other thing. This meter right here. It's a nice meter, but once you start getting under, it's good. It's accurate within an amp, I guess you could say. But if you notice, it's floating up at like 1.2 amps. I can, of course, zero that, but I'll end up floating all over the place again just by moving it around and stuff. So it's only so accurate. It works good for testing other things. But it looks like we're good. I'm going to put this back together. I'm a little bit worried it might fall off, but I don't think it will. It should stay on there pretty good. Okay, so I went off and I removed the diode, and I also did some current measuring differently. Before, when I was measuring, it would automatically adjust and regulate itself to putting out the same amount of current that it was and the same amount of power. So basically, with the resistor that's in this, in series with the LEDs, it was putting out the same amount of power. The way I was powering it right now, it wasn't doing that, so the voltage was dropping, hence less power was going to the LED. It was making it look like it was less efficient than it was. So I redid some calculations, and this is the voltage, this is the current, that's the watts, that's the watts right there for the input, and that's how much watts was being wasted on the LED, or not, other than the diode, my bad. As you can see, it goes after, instead of 6, it's actually 5.6. And this is without diode, it's 92% efficient. This is with diode, which is 83.5% efficient. So I just thought I would add that in there. I'll make a next project where this is actually a floodlight / flashlight. I got the battery right here, and this is a Kong long battery, and it's got a 0.3 or 3 amp hours. It actually came with this pack on it. I stuck the sticker back on the side because it's like only buy this genuine battery, and it's like $36 or something like that to buy their battery, basically with that sticker on it. So I went off and peeled the sticker off and looked at what it was on the other side, and you can get this battery at Sears for like $11. So